Hey everyone, it's Miss Barber here with lesson 5.8 in geometry, which is special right triangles. So this lesson is a little bit tricky because we are going to be dealing a lot with square roots. So I recommend if you are unfamiliar with square roots to kind of look into them a little bit more and how to simplify them. Okay, so to start, we're going to talk about our first type of special right triangle. This is a special right triangle of 45, 45, 90, meaning two of my angles are 45 and one is 90. You may or may not remember from chapter 4, that means this is an isosceles triangle. Two sides are going to be the same, and then the third one, the base will be different. There's actually a pattern with 45, 45, 90 triangles, and you'll see it here in the triangle, then also in my chart. Opposite 45-degree angles are going to be the same. So in the triangle they call it X, but to not confuse it with other X's, we're going to call it A. So whatever is opposite the 45, your two legs will be the same number. Opposite 90 degrees, the hypotenuse, is going to be A times the square root of 2. And this will always be the case. If you want to know why, let's look here. This is a square, and I know it's a square. All four sides are going to be the same, so I have a right angle up here in the corner. I can draw a hypotenuse in. So using Pythagorean theorem from lesson 5.7, my hypotenuse would be c, and I could say 1 squared plus 1 squared equals c squared. Well, 1 squared and 1 squared is 1 and 1, so I would get 2 equals c squared. And then when we did Pythagorean theorem, we learned we had to take the square root of both sides in order to get c by itself. Well, when I do that, the square root of 2 is not a whole number. It's going to be a decimal. It's an irrational number. So I could just say c is root 2. So I would get 1, 1, and then root 2 for my c. Well, root 2 is the same thing as 1 root 2. So that's our first pattern, 1, 1, 1 root 2. What if instead I made my sides 2? So let's go with the next biggest number. It's going to be the same process. I'm going to do 2 squared plus 2 squared equals c squared. 2 squared is 4, so 4 plus 4 is 8. So 8 equals c squared. Now I'm going to take the square root. This is where simplifying square roots is going to come into handy. You could put the square root of 8 in your calculator and you're going to get a decimal answer. But I want to simplify the square root. So I want to find the largest perfect square that goes into 8. Well, the largest perfect square that goes into 8 is 4. So I can rewrite the square root of 8 as the square root of 4 times 2. Well, the square root of 4 is 2, so I'm going to get c is 2 root 2. So my two legs are 2 and 2, and my hypotenuse would be 2 root 2. I'm going to do it again, but now I'm going to do it with 3. So I'm going to call both my sides 3. So I'm going to say 3 squared plus 3 squared equals c squared. 3 squared is 9, so 9 plus 9 is 18. Again, I'm going to take the square root of both sides. And I don't want to put it in my calculator. I want to think of the largest perfect square that goes into 18. The largest perfect square that goes into 18 is 9. So I can rewrite this as 9 times 2, And the square root of 9 is 3, so I'm going to get that c is 3 root 2. So you'll notice that it's always in the pattern of the two legs are going to be the same, and the hypotenuse is going to be root 2 times the leg. So in the first case, it was 1 root 2, and my legs were 1. In my second case, it was 2 root 2. In my third case, it's going to be 3 root 2. My two legs are 3, and my hypotenuse is root 3 times that. So that's how we're going to do all of these problems, where before with Pythagorean theorem we needed to know two sides. For special right triangles, we're only ever going to need to know one side, and we can find the other 3. So this chart up here, the 45, 45, 90, A root 2 chart, we're going to recopy that down every time for every problem. And the reason we're going to do that is first, it's going to help us organize our information, and second of all, it's going to make it so that we easily remember these ratios. So let's start. So again, before I do anything, I'm going to draw my chart. So it's 45, 45, 90. And then it's A root 2. So that's just recopying my chart down. Now you're going to look at your triangle, and you're going to see what they labeled. Right now I have a 90-degree angle and a 45-degree angle, so by default this angle also has to be 45. We can fill that in. And then they told me this side here is 11. Well, 11 is opposite 45. So what that means is I'm going to substitute 11 in under 45 in my chart. So I'm going to write 11 down here. That's saying A, of this formula, A is 11. So again, A is going to be 11. So my two legs are going to be 11. A is 11, so A root 2 would be 11 root 2. Now to answer my question, they said find the value of x. Well, x is opposite 90. So in your chart, you look to see what you wrote for 90. Well, for 90, I wrote 11 root 2. So my hypotenuse opposite 90, x, is going to be 11 times the square root of 2, or 11 root 2. That will be your answer. So let's try another one. So again, you're going to rewrite your chart. So I have 45, 45, 90. And then A root 2. They gave us a 90-degree angle and a 45, so I know my other angle has to be 45. And then looking, they labeled 2 root 2, which is opposite 90. So I'm going to have to write 2 root 2 under 90 in my chart. So what my chart is saying is that A root 2 is equal to 2 root 2. So I could write a mini equation here. A root 2 is equal to 2 root 2. Well, remember, I want to get A by itself. Well, how do I get A by itself? Right now there's a root 2 with it that I need to get rid of. It's multiplication, so I'm going to divide. Dividing root 2 on both sides, they're going to actually cancel on both, and you'll be left with A equals 2. So then I can fill that in under A for both A's, because those are my two legs. They're going to be the same. Now I go back. They wanted to know X, which is opposite 45. Well, underneath my 45s, my side length is going to be 2. So I can say X equals 2 for letter B. Moving on to letter C. Again, we're going to draw our chart. So 45, 45, 90, and then A root 2. So across from the 49s are the same. Across from 90, we will root 2 times it. They only gave me one angle here, 90, but they told me these two sides here are the same. Well then, if those two are the same, I know these two angles have to be 45. Now, they gave me 15 root 2, and those are both opposite 45. So I can go ahead and write 15 root 2 underneath both 45s. So what this is saying is that A is equal to 15 root 2. So A root 2 would be 15 root 2 of my A times root 2. So these root 2's are the same. So my A is 15 root 2, and then to find what's opposite 90, I would multiply by root 2. You could use your calculator, or you could figure out that 15 root 2 times root 2 is the same thing as 15 times the square root of 4. And the square root of 4 is 2, so it would be 15 times 2, which is 30. So opposite 90 would be 30. Opposite 90 in my triangle is x, so x would be 30. And again, if you're not great with square roots, if you're just trying to multiply them, your calculator should be able to do that for you. Last one is letter D. Again, you start, as always, with your chart. So 45, 45, 90. x, 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 or sorry, a is the letter we were using. A root 2, or a times the square root of 2. Look in your triangle. They labeled these two sides are equal, so even though they didn't label these angles 45, I know they have to be. They told me this hypotenuse is 7. Well, 7 is opposite 90, so I'm going to put 7 in under 90. Again, this is saying a root 2 equals 7. I don't want to know what a root 2 is. I need to know what a is. So to get a by itself, I'm going to divide both sides by root 2. Unlike my other example, my root 2 is not going to cancel. So I would be left with a equaling 7 root 2. Now, in math, you are not allowed to have a square root in the denominator. That's not something you're allowed to do. So to get rid of it, we're going to have to multiply both the top and bottom of the fraction by the bottom square root, which in this case is 2. So I'm going to multiply both the top and the bottom of my fraction by the square root of 2. Multiplying across, 7 times root 2 is 7 root 2. I can't multiply them together. One's outside the square root, one's inside. Root 2 times root 2 is the square root of 4. Well, we actually did that if you look back at example C here. We did the square root of 2 times the square root of 2. When we did that, we got the square root of 4, which ended up just being plain old 2. That's because when you take a number and a square root and you multiply by itself, so this is the same thing as root 2 squared, what happens is the square and the square root cancel and you're left with just the number, which in this case is 2. So now I no longer have a square root in my denominator, and that's called rationalizing the denominator, and we're going to have to do that a little bit in the next part as well. So again, if you have a number divided by a square root, you have to multiply the top and the bottom of the fraction by the square root, like here, so you get root 2 over root 2. And then multiply across. The square root should cancel in the denominator, so my answer is going to be 7 root 2 over 2. That's what a is, so I can put that in for both, 7 root 2 over 2. And we want to know x's, which are opposite 45. Well, that's what we wrote, opposite 45. So it's going to be 7 root 2 over 2 as your answer. I'm going to pause the video here. So that is one type of special right triangle, 45, 45, 90. Stay tuned for the next video for the next special right triangle, a 30.